That means we can start installing this on the back of the Dyno and do our further programming later, but that way we have the base of the smart light put together and powered. So we're going to go from there. Alright, so the other thing I'm going to do is add buttons for later controlling this Pi without having to sign it in through SSH. And so you'll need 1K resistor, 2 momentary buttons, doesn't really matter what model, whatever you're comfortable with. Mine are super small, and some wire. You're going to take these momentary switches, bend 2 of the feet in and bend 2 of the feet out, so that way they can be mounted on the back. You can reach up underneath and pinch it. We have 2 of those like that. I'm going to hot glue those onto there after I wire them up. I'm going to pop the board back out and set it up so one of these is going to be shut down and the other one is going to be the mode selector. So for one, I'm going to use a little bit of yellow, and let's see, the other one we'll use blue. Should be enough. So we're going to cut this in half. Something that a lot of people don't realize is that you need to debounce these, aka when I push down on this button, even though we're hearing one nice click, you usually don't get a super crisp connection between the button. So you end up seeing it turn on and off like super fast. It's fast enough that you or I would not be able to see it really with our eyes, but slow enough that our computer can actually see it bounce up and down, since our computer is many times faster than we are. And so basically what we're going to do is have a pin held low, and once it goes high, it'll tell the board to activate whatever function we're deciding to activate for it. To do that, we're going to do 3.3 volts because that's the logic here. So we're going to go off of the 3.3 volt pin, provide power to both of these buttons, and then also have a 1K resistors. We're going to take power from the 3.3 volt to create a pull-up resistor. It is going to be 9 down. 1, 2, 8, 9. So it's going to be right there. But we want it to come through the other side. Set that in place. Grab this. And we're going to solder that right in place. Alright, so we have our 3.3 pull-up resistor, and that's going to supply the power to our 2 switches, one blue, one yellow. Alright, so normally you would debounce these with a capacitor across the switch, but since we're using a computer anyways, we can basically do it with some programming. Shorten this up. We're going to pre-tin our wires. We've got our 2 solder hands here. I am starving. Just in case anybody wanted to know, come bring me a pizza. We're going to go in with heat shrink. Put it over both lines. There we go. We've got our power line, and we'll just shrink that up later. And then we're gonna strip these back, twirl them. I think I'm gonna go across the way. Either side is ground, so I'm gonna go on GPIO 23 and 24. Use my lighter. Tighten that up. Ooh, that's still hot. All right, and that kind of gets that out of the way so I can connect this one and this one. We're gonna come up through the bottom when we do that. All right, there's one, and there's 2. So now we've got our 2 wires coming off of the resistor that gives us 3.3 volts, And then we have 2 lines going to individual GPIO pins that will let us see what's going on those. Going to strip back these wires. And then all of this is going to actually be put through the bottom of our case here. Might as well do that now. There we go. It's in place. And we've got all our wires coming out the bottom. Gonna kick them off to the side here. Twirl these together, make it a little neater. Just match these up. Soldering iron again, and we're going to tin all of our connections. And we're going to take our 2, and I'm actually going to grab a little bit of heat shrink again. And so before we do this, we want to put our heat shrink on. You want to put it away from the connection again. Oops, I put 2 on the same one. At least I realized it before we had actually soldered anything. All right. That makes that nice, clean connection. Now we're going to do the same with our blue. I'm going to put my DMM across this just to make sure that I have these oriented the proper way. All right, so now that we've confirmed that our wiring is correct, we can take the lighter again. Now that this is all nice and wired up, we're going to grab our piece of wood and start laying out how we want to put the lights on this. All right, so now we've got our dyno. We need to figure out where we're putting this. I think we're gonna just put it like right in the middle there. I use Velcro to put that on there. I always like making it so I can undo what's on there. And then these I can put wherever I want. I could even go like this. I kind of want them hidden. Could also do it where I have one on each foot. Then we look at this. The nice thing about WS281X models is that they are segmented. So if I need to, I can clip this to make changes and stuff like that. So like if I'm going down these legs, I might need to route some wire and then bring it back up so that way it gets around the edges. We'll have it right in the back here so that way it's closer to this control board and also keeps the power wire where we need it. We're going to peel this back. There we go. I'm going to need to make this turn, so and it's okay that it has the dips here because it's going to be offset from the wall anyways. Again, for some of these sharp turns, you don't have to do this crease technique that I'm using here. You can use splice method. And then this is where our first splice is going to happen. We're going to do 2 slices here. I don't like how that is so bent up. Making sure that the data line in is still proper. So the way to cut this is to right on that line, where the line is. There we go. All right, so now we need to rewire all this stuff back together. So you can get 3-conductor wire that is designed for attaching these together. If you don't have that around, you can just use straight up this, and that's fine. Another thing to keep in mind, the only thing that needs to be in order is the DO line, which is that center line. That line is what has to be connected in order. So that being said, instead of running all the wires back, I can run my green, basically go off that DO, run it back, and keep the data line going. All right, so on all these connections, this is the process that I have been doing so far. I've been going in and pre-tinning the connectors. And then I go and take the piece of wire. I check how long it actually needs to be. So this needs to be about that long. I go ahead and just take off a tiny bit, cut off the excess, tin the ends. I'm going to just lay that right flat. There we go. So there's that data line coming from there, going over to here, and it's going to continue out this way. All right, so now going to connect the power. By the way, as you're going through this, you're going to want to set your DMM to continuity, put on the 5-volt, and you're going to just check and make sure that your solders are good as you go. And then you're also going to want to check between the different lines to make sure there's no continuity between the lines. And it's good to do that as you go, because then you'll know, okay, the ones I've done so far are okay, and then something just shorted it out. Instead of doing it at the end where, okay, now I got to figure out where of all the work that I've done is the problem. All right, so we are on the last little bit here, and we're going to basically be taking this and continuing the circuit around. For this, it almost makes sense to do naked wire because it's just too much of a pain. And what I can do is basically start bridging that together and then cut it. All right, so this whole thing's tinned. And we use the wire as our handle. And then just going to, there we go. There's that end. Be careful because it's going to be really hot. And we cut this to size. There you go. Now we have our bridged wire there. Do that again for this connection here, and then we're going to use the regular wire on the outside. Our last one. And there we go. Go around with the DMM, make sure our data line is, well, I don't think the data line actually goes through. It does not. Which makes sense because it has to go through the chip. Just make sure my ground connection is good and my 5 volts is good. Awesome. So that should mean that everything is ready to try out. Pop this cover off for now. Right, so now we have to recount our LEDs. So we have 1, 2, 3, 4, 6, 67, 68, 69. I did not mean to do that. Okay, so now we're going to change the count Swear to God, did not do that on purpose. Control O to save it. Control X to close. Sudo Python 3 space examples slash strand test dot py. That's perfect. And right now we're only drawing about an amp. Then we're going to go to the white test. So the maximum that this is drawing right now is 2.5 amps. That is nice and bright. Just put maybe a support here and maybe here, and we're good. Alright, so I've got a couple blocks here. Basically, as this hangs, it'll keep the feet and stuff away from the wall. So I found some Velcro, which I'm going to use. Alright, so I decided to put the momentary switches there, hot glued them in place, so that way you can kind of reach around, and this is going to be the mode button, and then this will be the shutdown button. It's kind of harder to get to. You got to really reach up in there. I went with larger blocks here and here. That is so that way I can actually put picture hanging frame teeth in this area. Should work quite well. So now we're going to drill some pilot holes, at least for the anchor points. The other ones don't really need. Got a 1/16 inch bit. This is probably overkill, but with this other one, I'm pretty sure I can get away with just 2 screw points. So basically we have this adapter, allows us to connect in. So what we're going to do here, we're going to tin these positive to positive, open these up. All right, so that's in. Yeah, I think we're going to go with that. Then we're going to take one of these, and this will go around that. So I'm going to grab my hammer, and we're going to hammer that in place, and then we are done with the construction side of things. There we go, held in place. Good, good, good. Now for the programming. All right, so here we are on the computer again. We're looking at the offline Dyno main script that I've written for the smart light. You can find this linked in the description below, and I'm just going to go over this real quick with you. This is derived partially from the strand test that we used in the examples, and has some additions to allow us the buttons, which also shut down or change mode, and then also the smart feature. So just giving you a quick tour, we've added the debouncer for the buttons, then added the buttons in here and set them to pull downs. Then we have a few custom functions that are added to take care of changing modes, which is right here. Then changing of certain pixels is my custom code here, setting the color all at once instead of the wipe that comes with strand test, and then the ability to just set the body to a certain color and the eye LEDs to a certain color. Moving on, this is all code that was in the strand test, so I'm going to skip right over it. We've added a shutdown and event detections for the buttons being pressed, and they call the appropriate shutdown and set flag true for mode change. Now we're into our main program, which will loop infinitely. The loop starts down here. This is all from strand test again. And then we go into the demo mode, which has its own loop here. Each time we change what is going on in the demo, we check to see if the button has been pressed to change mode. If so, we break out of here and go right into the solid color sets, which is this right here. It'll do the primary and secondary colors, changing colors each time you hit the mode button. Here is the pièce de résistance, the smart monitor for the network connection, where it's broken into two parts, a loop down below and the initial setup, which sends a lot more packets and pings to the devices to allow you to troubleshoot as it's starting up. Basically, it will set the lights to red, then ping on a 2-second interval our router. As you can see, I've set the IP address appropriately for mine. You might have to put in a different IP address. Once it gets that ping back, it'll say, oh, I've detected the router, and set the lights to yellow, and then continue to pinging the Google DNS server, which is at 8.8.8.8, and that's on a 2-second interval as well. That's a lot of packets, and that's why we don't do this later on down the line after initial setup. Once you've established an initial connection, it goes and does one more ping on the router and the DNS, and then waits for a total of 2 minutes before pinging again. And then every 2 minutes it also checks to change mode. Once you come out of that, it'll go into a lights off mode, which is good for if you need to go to bed or something like that and you want this to not be emitting light. Hit that mode button, it'll turn off all the lights while keeping the Pi up and running. Finally, we have the keyboard interrupt that was taken from the strand test, which allows you to shut it down. So that's that. Now I'm going to show you how to take this script and put it on the Pi, as well as setting it to run that script right from boot. Alright, so we're going to go back to PuTTY, into our offline Dyno light, password in, and then we're going to do sudo nano with no file name. Select all of this, copy it, right click inside our window here, give that a couple seconds to get all the way down. I know that's the last bit of my code. Hit Control X, hit Y for yes, and we're going to name it the same thing. So it's offline Dyno main.py using camel case. Make sure that no spaces in that name because it does not like spaces. You can use underscores if you want. Really, you can name this whatever you want, but you got to remember the name you use. Okay, so now we're going to hit enter. And to make sure that was created, we hit ls. There it is. To make this run on boot now, we're going to write sudo nano /etc/profile. We want to go to the bottom of this using your arrow keys. Just keep going until you get all the way to the bottom. Going to give some space. We're going to add sudo python 3 / and then this is where you put where we've created our offline Dyno main script. So I know ours is in the home directory and Pi, and then we're going to specify offline Dyno main.py. And since this is a looping script, you want to add space ampersand. And the reason why you do that is it allows the script to go on running, but it lets the Pi go and start doing other processes in parallel. So this is not going to lock up the Pi completely. We can override what it's doing. Now that we have that in place, we do Control X, hit yes, and enter. Since in our new script we're using the debounce, we're going to need to install some additional libraries. To do this, put in sudo pip3 install adafruit-blinka, and that will install all the requisite libraries. Now we're all set. What we can do is reboot, and you should see after about a minute your Pi turn on its lights and start doing the demo mode if you've done it correctly. And we'll show you that sweet B-roll footage. we're back with this shiny distressed beauty. It's been a blast working on this. I'm so happy that you guys joined me throughout this process. I learned a lot. I hope you guys learned a lot. One of the things I realized I forgot to mention was the hardware we use for the hanging. And those are sawtooth style picture hanging hardware that you can get from any craft store or online at Amazon. So that's pretty simple, cheap. It's like $5 for 100 of those with the little mounting brads. I think it's been a pretty good learning process. Learned some new Python skills. I've never done addressable LEDs before, so I have a lot of projects that I have in mind going forward to use this new technique with. If you happen to have any questions about how to use this technology, leave them in the comments below. I always love getting back to people and investigating some of the things that you guys are interested in. Leads me down stuff that I didn't even think of. Another thing we need to look at some point, there seems to be an issue where the Pi is crashing. So I'm not sure if that's due to a memory leak with instances just not being closed out. And then the other option is that it's dirty AC power because we've got like 10 different things plugged into the same strip. So that could be causing it to glitch out. Anyways, if you guys find something when you're poking around in the repository, let me know. We'll get the word out to everybody. If we happen to figure it out on our end, my wife and I, will make sure to get that out to you as well. Next up is a build and review of a standing desk. We've all been starting to work from home a lot more. Ergonomics is definitely vital to maintaining a good work environment from home. So make sure you hit that notification and subscribe buttons so you don't miss out on that. Thanks for joining me. I'll see you again soon.